Welcome. I'm Carolyn Grimminger with the Public Affairs Forum of the First Unitarian Universalist Church of Austin. For more information about our public affairs forums, you can go to our church website at www.austinuu.org. Today's speaker is Dr. Bruce Naylor, and his topic is Politics from a Brain Science Perspective. Dr. Naylor has taught computer science at the University of Texas at Austin, Georgia Tech, New York University, and Rutgers. In addition, he did research at AT&T Bell Labs for 10 years. Currently, he is an adjunct professor in the neuroscience department at Baylor College of Medicine, where he is planning on using virtual worlds to combine brain activity research with MRIs to treat PTSD. Today, he will discuss the evolutionary forces that have shaped our brains over the last 10,000 years, the resulting warrior brain that we all share, and their manifestations in today's political environment. Let's welcome Dr. Naylor.
Thank you. So all of us, I think, have been surprised at the political developments over the last year, and are confused to a certain extent. And so the motivation for this talk was to try and see if I could bring scientific perspective to bring some order out of chaos. And if so, this will have maybe the beginnings of an approach to political discourse that will be much broader than just our current moment in the U.S. Okay, so I'm going to explore understanding social science from a neuroscience perspective. So that's not something that people have done too much of, different camps, neuroscientists and political and social scientists, but that's the approach I'm going to take to try and bring some order out of chaos. And I'm going to emphasize the role of genetics in brain functioning. And you may go, what does this have to do with politics? Well, that's what the talk's about. And I just might say at this point that while people have become accustomed to thinking in terms of genetics, in terms of human traits that they can easily see, like hair color and eye, and how children look like their parents and that kind of thing. The same kinds of ideas apply to our brain. But since we can't see our brain directly, unless you have very expensive machines, you don't realize that's going on. So that's the angle I'm taking, because I've done research where we actually get to see the brain. I'm going to focus on the impact of all this on political behavior. And I'm going to introduce a concept I call the warrior brain. And Roger Ailes is a good example of someone with the warrior brain, just to give you a preview. So the goal is to increase your understanding of humans as political animals, both literally and in the symbolic sense. And hopefully this will lead to greater empathy with the other side and more cooperation and reducing the divide that Roger Ailes had a lot to do with expanding. Okay, so I'm a computer science researcher, and you're like, why has he got pictures of video games up there? Because my research had a big impact in the 90s on video games, and basically enabled the transition from 2D to 3D games. So Doom and Quake and Call of Duty and Counter-Strike and tons of games, I lost count. So probably people guess into the hundreds of games have used the technology. And what the technology did was allow you to rapidly find out which subset of your virtual world was perceptible. So right now, if you think about where you are, there's this big church and there's all these buildings, and you can't see much of it right now because you're looking at me. And you can't see what's off to the side and what's behind your head, and you can't see through the walls. Well, that's what my technology allowed you to find that really quickly. So that's my history. However, the part of all of that that is relevant to the talk today is because this was the first time that the general public had access to real-time interactive 3D graphics, because this coincided with the development of the reduction in cost and increase in power of the PC. So we had PCs everywhere, had PCs in the home, PCs in the work. They got this game, and just millions and millions of people became obsessed with it, playing it over and over. And these are people who, you would look at them, you would not think that they would ever be into violent games. But they were. It was tapping something very deep in our psyche. And so that was my first clue that there was something more going on here than merely entertainment. Okay, so recently I've been doing more neuroscience than traditional computer science, but being the computer scientist part of a team with people who are on the neuroscience side. And this is one of the experiments have been doing, where we have this using game technology, and this was a setting in the Middle East, and it has a bunch of soldiers, both friendly and not friendly, and one of them at random pulls out a gun, and the subject is supposed to click the button when they see it. It's a very simple experiment. It's simple because that's as hard a problem that we can address at this time. The brain is so incredibly complicated. You have to really do simple things, and actually what we were doing was very cutting edge, pushing that envelope much further than most people. Doesn't sound like it, but it is. And over on the right side, the colored areas correspond to degree of activation of different parts of the brain. So that's how a lot of cognitive neuroscience is done. You give some stimulus and you see which parts of the brain light up, is the phrase. It's not really lighting up, but we illustrate it with colors. And let me tell you about the neuroscience perspective. So neuroscience has been around for a while, but it's really been picking up momentum. And the headline is that the brain controls the body and creates the mind. So for millennia, we were puzzled by, is there a connection between the mind and the body? And this has been discussed on and on forever. And in hindsight, you go, well, yes, the answer is very simple. It was right under our nose, or above our nose. It was the brain. But we couldn't see the brain. We couldn't see it. And we're really, really bad at things we can't see. I mean, what else could possibly be the case? You got to have the data coming in. So actually, the brain is creating the mind, and it's controlling the body, and it's one giant integrated system. And so we are a stream of consciousness that's the result of all this processing, taking all our sensory input, sight, sound, touch, all that good stuff, and creating an integrated mind, brain, body system. This has huge ramifications, of which I'm only going to be nibbling on them. Not that I know all the ramifications, it's just one of those sea changes in the history of understanding the humans have of the universe that's going to have implications for a very long time. Okay, so second headline. The 3D world is synthesized in your head. It does what you are. This is a trick that's going on that you're not conscious of, that your consciousness is being created by your brain by taking input. This is a really difficult concept initially to get your mind wrapped around, because you're experiencing the world and it's all out there and it's real and it is out there and it is real, but you're not perceiving it directly. What you're perceiving is something that's computed by the brain, from photons hitting the eye, from sound waves hitting the ear, from the neurons detecting the position of your joints and all sorts of other properties. All of that is coming in and being integrated into a model of the world. And your visual spectrum only encompasses a small fraction of electromagnetic energy spectrum. So the simplest way to think of this, I think, is that we're watching a personalized video of the physical world. It works because it is based on the physical world, but it's not identical to the physical world. You all know that some people are quote-unquote colorblind. They can't see the same colors that other of us see. They only have two of the basic colors rather than three. So what we have shared is the physical world and our genetics, which have been selected over millions and millions of years to do a good job of creating this experience and making it accurate so that you can make decisions to stay alive, because that's the fundamental name of the game. Staying alive, and then if you do that, procreating. The biological differences result in different experiences. So we all know everybody's different. Why are they like that? Why are you like that? You're different. Yes, you're different. Well, your biology is different. That's why. And everyone's a little bit different. So we all have different experiences. And if we can get this in our head, then maybe we can stop having such strong reactions to people with different views, as long as those people start understanding that the differences are based on biology and experience and lots of things. And that no one has a handle on the ultimate truth because it does depend upon your particular biology. At least the details do. Okay, and just to kind of finish up this I have a little optical illusion over there on the right. So how many people see a duck? How many people see a rabbit? Okay? This is very simple evidence of my thesis that your brain is constructing your video, because the input's not changing, the physical world's not changing. So if you had any trouble with that, the duck, this area sticking out to the left, if it's a duck, that's the duck bill. If you're seeing the rabbit, it's the ears of the rabbit. All right, so add that to your political arguments. All right, so here's just a very simple atlas of the brain. As you can imagine, it's a lot more complicated than that. And with MRI, functional MRI in particular, we've been discovering how complicated it is, and it's really complicated. I would say all of neuroscience is contributing to that realization. But all I really want to do is kind of get you oriented toward thinking about there being an architecture underlying the brain. And this is a simple picture. So at the far back of the brain, you have the visual system, input, the visual input. And then in the middle of the brain, next to your ears, you have the auditory processing system. And then down the middle of your brain, slightly to the rear, you have the input from all your muscles. So those are all inputs, and so the back half of the brain gets the inputs, the sensory inputs. The front half of the brain controls the muscles. So everything you do is just muscle control, except for maybe your thinking. But anything that anyone else experiences externally, it's muscle control. And so right adjacent to in the middle of the brain, the primary sensory area, right adjacent to it, you have the primary motor area. And then let me just call out one other feature that this diagram shows that's special, but it's a very special part of us. It's speech. And the speech listening part, the speech interpreting, processing part, is on the left side of the brain to the rear, adjacent to and in between the auditory processing and the visual processing. The output, the motor control system, is in the forward part of the brain and down to the left. So both of them are on the left. So this is the one feature of human brains which are extremely asymmetrical. So left side, most people, the speech system is on the left. All right. The key point I really want to say is there's an architecture here which should remind you, not specifically, but you should think of it like your skeleton. It's as defined by genetics as your skeleton is. You come out with 2 arms, usually, and 5 fingers on each hand, et cetera, et cetera. And we look around and we go, oh, all human beings have these features. Wow, that's interesting. How could that be? Well, that's in the genes. So just a simple rule, if everybody has it, it's genetic. Everybody doesn't have to have it in equal degree, but this is the genetic component. And I want to extend this genetic thinking into our behavior, because all our behavior is being generated by the brain. So it's not much of a stretch. So on the previous slide, that was really kind of a colored road map, or so to speak, like you have states, like a U.S. map, you have states. But that's not really what the brain is about. The brain is about doing information processing. And the information processing, you've got 100 billion neurons, and one neuron doesn't get you very far. And so you have to be organized into cooperating groups of neurons, and key to that is connecting neurons. So the picture on the left is an artist rendering of a neuron, which sort of emphasizes that there's a center core, and that does the arithmetic. And it's pretty simple arithmetic. It's just multiplication and addition of a bunch of inputs. And based upon that total number, it sends a number to everybody else it's connected to. And that's it, roughly. And then how you get complicated things is how you connect those up. And so what's on the right is a picture generated not by an artist, but by computer taking data from people's brains and showing the primary pathways that connect different regions of the brain. So you may see a gap at the very top in the middle in that connectivity. Well, that's good. We have two hemispheres. And there is indeed a gap there. There's no connections between the hemispheres at the top. You have to go halfway down, and then you have the connections through the corpus callosum to a large extent. Once again, just like your fingers grow, this is genetic. And this architecture is going to drive the behavior. So the brain's evolved over billions of years. Well, everything's evolved over, well, millions of years. But multicellular life is probably less than a billion years, so millions is a safe number. Cognitive traits common to all humans have a genetic basis. Just keep that in mind. A lot of what neuroscience is doing is trying to make the connection between structure and function. That's what I was alluding to just in the previous two slides. The large scale that I've been showing you and talking about is genetically determined. Why? Because we find the same structure in all humans, unless there's something goes wrong. The small scale varies with everybody. So the small scale is the result of learning and growing. And literally learning and growth are really intertwined in the neurosystem, in the brain. So just kind of a simple point, everyone has a hand with 5 fingers, and you have fingerprints, and everybody's fingerprint is unique. So the uniqueness of the fingerprint is the result of the growth process. The fact that you've got 4 fingers and a thumb is the genetics. So that's one simple way of seeing the two simultaneously. In general, brains are learning machines. That's really what they're up to. They're taking in data, they're extracting patterns for it, they're constructing models to predict how the world is going to work. Do recognition and prediction. And that's a growth thing. And as everyone had suspected, there's massive learning during childhood, and neuroscience has confirmed that that's the case. You have all this initial growth. In fact, you have an overgrowth, and the way the brain works is it sculpts out the useful parts. So it throws away, it does pruning is the term that's used, just like shrubbery, pruning away shrubbery, and it tunes the nervous system to operate as efficiently as possible. And there's a disproportionate amount of this happening in childhood for humans because our brain, which is 3 times the size of a chimpanzee, which is our closest relative, can't fit through the birth canal. So the trick that nature came up with, the workaround, was fine, we'll grow the brain postnatal, after birth. And we'll grow it a lot. And that provides this opportunity for enormous learning specific to the environment in which it's growing, because most of the growth is driven by perception of the environment. It's not encoded specifically in the genome. All right, so everything is grown, but from genetic starter kits. So it's not like the brain has no clue where to start. Evolution has selected rough approximations of what you want to do. So why do I have a picture of Teletubbies up here? Because newborns have a preference for looking at faces, and the neuroscience suggests that they are relying on a general shape of 2 eyes and a mouth. So not much. So the genetic starter kit is just this geometry, simple geometry. And then what happens? It grows the vision. The vision's not hardwired, but it's learned. And that's what we mean by learning. So it's not like, oh, I open a book and learned. This is the nervous system from the very beginning. The child's born is learning about the world. And that's constructing our vision. And to do that, it has to, here's something we all do know, it takes practice. You got to do it over and over and over and over. So even at this lowest level, you've got to have repeated exposure to faces. All right, so this continues on dramatically, certainly for the first 20 years, but even for the first 25 years, as the car insurance people have discovered through statistics that by age 25, people are much better at driving, and their accident rates go down. Okay? So here we have some neuroscience here to back that up. But there's one particular feature that I want to, so I've just been giving you kind of general neuroscience, even though my agenda was nominally political. So let me just switch over and connect this up a bit to political thinking. So we've had tyrants throughout history. Dictators, whatever you want to call them, pharaohs, kings, who some of them have done great positive things and some of them haven't. And of the ones that we have direct observation of today, and there's several in the world, it seems we see a pattern, which is they seem to act like teenage boys. And people were pulling out their normal pop psychology thing, and they were saying, oh, I've got to explain this, whether his father must have treated him badly. Well, his father may have treated him badly, and that, I don't know. And that would have had effects if he did. And there's no question that parents have huge impact on children, and that's is consistent with what I said, is that there's so much growth that occurs. But that's a very human level, whereas neuroscience is really working at this lower mechanistic level, much closer to computer science. And there's a rate of development, and what's been observed is it varies. Well, I think every trait that we've ever paid attention to about humans varies throughout the population, and usually to a bell curve, Gaussian distribution. So one thing that's been measured is that there's a point at which the development peaks. Now, there's the rate at which of development, so it's not the same all the time. So it picks up, accelerates up to a high velocity, and then it starts slowing down. And the earlier that peak is, or rather the later that peak is, the higher the IQ. So here you have another mechanism to sort of explain large-scale human behavior. Purely developmental, possibly just genetic. But you could end up with a feature of political structure, aka the dictator, that might be explained. I don't know that it is explained by this, but it might be explained by different rates of maturity and reaching peaks. Whether this is in fact the case would take a tremendous amount of research and money to substantiate at the standards that science demands, but I'm just speculating. And the point of my speculation is to shift your thinking about other ways of explaining what's going on. All right, so let me just move on to more of the social science. That's the neuroscience part. And the bridge is going to be natural selection. So just to remind you of natural selection, you have random genetic changes. They're retained if they improve the likelihood of survival. One thing people had underestimated is how much the genes cooperate in an ensemble form. So the ensemble effect, you have changes that impact how genes working in an ensemble with other genes. And an example of the shift in thinking was that when the Human Genome Project was fully underway during the 90s, part of the selling point of it was that we were going to be able to solve a lot of disease problems. And implicitly, I'm not sure the scientists realized this at the time, but they did in hindsight, implicitly they were sort of assuming one gene, one disease. And then they started getting into all this, and it's like they could hardly ever find that case. So there's one famous example of where that is the case, and it's sickle cell anemia, in which not only is it one gene, but it's one mutation on that gene that causes the geometry of the protein to hook into a sickle, and then those sickle shapes hook, they're hooks, and they just hook up and they just all coagulate into a mess. But most diseases are ensembles of genes. So now when you're looking at a mutation, it's not just, oh, this gene only does such and such, and it either improves that or doesn't. It's how it impacts all the other genes. So it makes it much more difficult for the scientists to tease all this out. All right, so the basics of natural selection, the type of selection that everyone has always been focused on is selection for the individual. So you have some mutation and this individual is better at survival and reproduction. But in the 60s, they certainly dawned on them. They were trying to explain altruism because individual selection suggests a strategy that's what we would think of as selfish or narcissistic. And then the scientists were going, wait a minute, but that doesn't explain all the human behavior. Humans are not overwhelmingly selfish. Actually, it just varies in the population, how much they think about other people. So they started thinking a little closely, and they realized, well, if you just look at the arithmetic of genes, a parent's genes are shared by each of children, but for one parent, since each child gets only half from that parent, then that child shares half of the genes, and then the next generation is going to be, the grandchildren are going to be a quarter of the genes, and the nieces and nephews are a quarter of the genes. And so now you have, if you view this from the perspective of the genes trying to replicate themselves, that's the fundamental game going on, then you realize, oh, okay, there would be a genetically driven win if people wanted to help the survival of their kin because they're propagating some percent of their genes by doing so. All right, so that's well accepted. And then the last one was one of these ideas that Darwin introduced, and then people kind of backed away from because they couldn't come up with a mathematical model. They couldn't come up with an explanation. But I would say, having read Darwin's original books, I would not ever undercut Darwin. He was incredibly gifted. And there's something about being at the beginning where you just have this huge energy rush going through. You just see things. So a person who is in some sense, maybe not a successor to Darwin, but pretty close to it, is E.O. Wilson. And he reintroduced group selection because his whole research was the social nature of animals. And his specialty was ants and termites. And he said, well, there has to be a genetic basis for all this behavior. I'm seeing lots of really clear behavior. And if you've watched your nature films on bees and termites and ants, you go, oh yeah, there's a lot of behavior. And it keeps happening with all of them. So this leads us to a prominent feature of humans, and that is that we are social creatures. And so the picture in the right, upper right, is a troop of baboons. And the picture on the lower right is a group of hunter-gatherers in Africa. Okay, why, if we are social, or if any, there had to be some advantage to it, genetically. That's the rule. In order to get it in the genome, it has to be selected for. Doesn't mean that this is the only solution to life. There's plenty of creatures that are not social, but we are. So people thought about this a little bit, and they said, well, here's some obvious advantages just from observing primates in the wild was always a good one. So protection from predators. So there's value in having lots of people, lots of members of your troop, if for nothing else, for having lookouts and sounding the alarm, which definitely happens with monkeys. So they have a lookout. Okay, there's a leopard. They sound the alarm. They yell. They do a call. And then the rest of the troop knows that danger is lurking. Mutual defense, which probably is certainly like in the case of baboons, they do fight each other. And so you want to have, just like with humans, you have your team versus their team. And there's safety in numbers. On the less aggressive side, you have shared rearing of young and shared collection of food. So those are just some straightforward advantages of being social. In human, of course, we are primates, and so we inherited that genetic heritage. So for us, cooperating in hunting and gathering, cooperation in agriculture and constructing housing and buildings and fortifications, and then more complicated behavior, warfare and religion, probably our most complicated aspects of our nature. And then after we had that as a basis, and in recent times, the acceleration in the evolution of culture has been driven by creating knowledge and transfer and application. So STEM, science, technology, engineering, and math. Okay, let's look a little bit at our social structure, and then we'll start being able to see some more connections to politics. So you can't have politics unless you have a social structure. That's the whole point of the social, bringing in the social thing. Politics is an activity of social groups. So there's a hierarchy, social hierarchy in animals, and the most well-known is pecking order, which I guess came from chickens, observing chickens. And chickens are not primates, and if they derive from dinosaurs, then we really split from them a long time ago. But you see that independent manifestation and evolution multiple times, like the eye got evolved and invented multiple times, although there still may be some ancient commonality to it. There was just areas that were sensitive to light. At any rate, you have packing order, alpha male, alpha female. Key value of that was higher ranking members receive more benefits. Benefits are food, shelter, protection from predators, and ultimately they do better in competition for mates because their ability to acquire resources allows them to attract mates. So about 20 years ago, a little over 20 years ago, Franz de Waal came out with this book called Chimpanzee Politics. I don't know if you can read the title. That he studied chimpanzees in a massive zoo in the Netherlands. So it was made to be as natural as it could so they could see authentic behavior. And he saw lots of behavior that could only be interpreted as political. So you had alliances and battles between groups of the alliances, all trying to be the alpha male. That's what it was about. Climbing up in the social hierarchy. And his book detailed all this. Interestingly enough, he did not actually spend much effort at drawing the parallels with humans because he didn't need to make that effort. It was obvious to the reader. So we were like going, oh, we thought this politics stuff was just, unique to humans and some sort of advanced. Okay, well, we can see the genesis of it in chimpanzees, which we split from like 7 million years ago, roughly. Going back over to the bird side, so the peacock is one of those classic examples of the effects of competing for mates. This is sexual display. It's like, come mate with me. I have great genes. You're advertising your genes, the health of your genes. Okay? And humans have this same thing. So we have drive for social success. So rather than having our peacock bloom, we buy automobiles that are expensive and have houses which are arbitrarily large and clothes that are pretty close to the peacock in ways. And then we have hierarchy in our organizations, and this gets us obviously much closer to the political question. So we have presidents and vice presidents over here, and historically we have gods and kings, and you're like, wait a minute, why did I put that together? Well, because for a lot of societies there wasn't a distinction between those two categories. The pharaoh is divine, and even as recently as Japan, the emperor was considered to be divine, whatever they meant by divine. I don't really know. But it's all extension of this social hierarchy. It started out with small groups, and as the groups got larger, just got more hierarchy. And eventually you end up, so if you take the chimpanzee hierarchy and the peacock sexual display and add humans in it, you get a king in robes and a crown. And the crown obviously makes them seem taller because we have a genetic response to height. And people who are tall get better jobs and more money, with the exception of Napoleon. All right, so being a computer scientist, I can't help but add in a computer science perspective on this. So I thought of this idea of the social operating system. So I'd just been noticing for a very long time how humans form little social groups. And if you're in academia, it's like every department is a social group. They have their own system, their own values, their own language, kind of the whole kit and caboodle, is unique to each department. And of course, then if you go to another university, you get another flavor of each one of those. So clearly we have this something supporting this socialization. So taking the metaphor of the operating system, so this is just neural software common to a social group. It runs on the brain architecture. So going back to what I was talking about, you got to have that architecture is going to have to support whatever behavior happens, which is why modifications to that architecture are required to support new behavior. We would normally call this culture, but it's the deep, low-level cognitive part of culture that people are not aware of. So it's not the, oh, they do this kind of dance in this culture, and they eat these kinds of foods in this culture. This is deeper. This is in the brain. People are not aware of. Sociologists have been telling us this for a very long time, because that's what they study. They study these cultures, and they go, yes, and no one seems to be aware of it. Continuing with the computer metaphor, we could say it's downloaded by social interaction, communication, and training. It's required. Why do we have this? Because there's this advantage to being social, and how are you going to cooperate if you can't communicate and have some sort of shared structure that everyone's operating from? They all have to be on the same page, so to speak. So language is the obvious. Got to have this shared language. That's communication. But even worldview, and we know about worldview here, having different worldviews, values, rules, ideology, all of that, that's the foundations of culture. What clothes you wear is not. That's details. And there's lots of group activities. The reason why we've taken over the planet, for good or for ill, is because we're incredibly good at cooperating. Look at all the buildings we've built, all the infrastructure. It's gigantic. All the knowledge we've created, the arts. It's huge. It's because we cooperate. So you need a mechanism for that. All right. Now let me go back to timeline. Just one slide on a small topic, the evolution of civilization. So we were hunter-gatherers up until the end of the last ice age. So however far back you want to go for humans, whether it's 4 million years, 2 million, 4 million, 6 million, depending on what you decide, where you decide to cut that off. So I said we split from the chimpanzees about 7 million years ago, so you could start there too. But we've always been hunter-gatherers. And part of that hunting and gathering is making weapons, by the way. Weapons maybe to kill food sources, but anthropologists find out a lot about human history by finding arrowheads and spearheads and devices that were designed for splitting open flesh. So these hunter-gatherers are actually quite small. They're not like the Indian tribe that, we grew up with seeing TV movies and all that. That's much larger. These were really extended families. So they had the kin selection I mentioned earlier about the genetics. They have this very strong shared gene pool, small, very small. Occasionally they'd get fresh blood from another source. But most of the time, if they encountered a stranger, they would kill them. And it's amazing. You say, well, how do they know this? This is because there's plenty of these hunter-gatherers still around today. And certainly when they started doing anthropology in the 1900s, in the 1800s, 19th century, there were a lot of hunter-gatherers still around. Not large as a percent of the total population, but they were small, but they were distinct, and so from a scientific perspective, provided tons of data to figure this out. So they had this instinct to kill strangers. So here's a question. Is that possibly the root of racism? That means it's deep in our genome, and it seems like it is. It's a reflex. We're assessing, we have a model in our brain based upon looking at lots of faces and we have friends and foes, and if we're familiar, if the face is familiar, we're like, okay, no problem, that's one of us. And if the face is too unfamiliar, it's like, oh, wait a minute, what's going to happen here? Is this person going to try and kill me? Or I'm going to need to kill them? Because that's what they did for a long time. And I, just as a real personal note, for various reasons, I had fear of strangers, but I love to go for walks. And when an unexpected person would come around the block, could be 1 block, 2 blocks, 3 blocks away, but I could just see them, boy, I would have this fear, this really strong fear reaction to them. And I've, with lots of work, have overcome that. So it's not mere speculation, at least not for me. All right, so for millions of years we were hunter-gatherers, then we had this gradual transition to agriculture and settled community. Why was that such a big deal? And why could we do agriculture? Because it required a warmer climate. And so crops and livestock provided far greater calories per person than hunter-gatherers. So anywhere like from 10 times to 100 times. So huge return on investment in terms of calories. So what did that result in? Increase in population. Started with bands, and then to tribes, and the chieftains, then to city-states, and then to nations. We just keep growing. Right? We're up to what? 7 billion, 6 billion, whatever it is. This increase in population allowed specialization in roles of society. So we started having all sorts of, we had a blacksmith, we had the farmer, we had soldiers. So let's move to warfare, which is where I've been trying to target the talk. So let me go back to group selection. So there you're selecting for more than just a family of genes. I mean, literally a human family of genes. You're selecting for something bigger. It probably started out as a family, and then maybe just became more and more extended. And when agriculture happened and people stopped being nomadic and stayed settled, you would then have more families possibly sharing, and that's how things grow in terms of shifting over to agriculture. And that did not happen in the blink of an eye. It happened over thousands of years, where you had a commingling of settled agriculture people and the hunter-gatherers, and that persists to today. It's just that the hunter-gatherer percent of the population's really tiny at this point. So I say warfare is gene pool competition. It's the mechanism for doing selections of groups. Why is it a mechanism? Well, it kills, kills your competition. A lot of times there's an impulse for extermination, at least of the male soldiers. For the women, it's a little different. Sometimes the winning force takes the females and adds them to their own social group. Religion gets in here and provides a unifying story, for example, the glory and afterlife. So, do your sacrifice for your gene pool. It's okay because there's an upside if you actually don't survive, and that is the afterlife. And you'll be a glorious hero in Valhalla. You'll have your 72 virgins or whatever the reward happens to be. But this is how religion can support the evolution of war, and war would support the evolution of religion. So they probably, this is all speculation, they probably co-evolved. Religion providing all sorts of social cohesion that wouldn't have been there otherwise. Synchronization exploded. Like, what synchronization? Why is he talking about synchronization? Well, going back to those pictures of the brain that had all the wiring. So one neuron doesn't do much. You've got to get millions of those guys working synchronously. to get anything happening in the brain. And shifts in those alliances is often how our brain changes states to different activities. So synchronization is at the brain level. Now, in warfare, you need synchronization. Also, it turned out to be very useful. So the Greeks really exploited the concept of the phalanx. And it had various manifestations of it. But it was very effective in terms, in their particular case, their primary, at least the time that this became prominent, their primary opponent were the Persians. And the Persians did not have this level of organization. They were a little bit more every man for themselves, just kind of be wild. And the Greeks were incredibly disciplined, held their formation, and even though outmanned by a lot, could be successful. And I'm not just talking about Thermopylae, where there was the 300. I read Herodotus as an undergraduate, studying Greek, and he chronicled the Greeks kind of just plowing over Persia. And it was a key to their success was this synchronization, where you have to do drills and marching. It's aided by drums in terms of synchronization. Trumpets actually were more for communication, but they were part of the whole thing. And I want to mention drums and trumpets in preparation for a slide that will be just a little bit later. Okay, so I propose this idea of the warrior brain. So what is this? That warfare shaped our brains. We have a brain architecture. If you're going to run major behavior on that, that architecture has to support that behavior. So warfare is a pretty major behavior. So with high probability, the architecture has been shaped in some way. And we don't really have access to that, and I don't have the means of yet of doing that. As I introduced at the beginning, I'm using the best we've got. And it's way underpowered for answering anything as complicated as this. But if we just step away from having to need neuroscience to identify this and just stay on the speculative side, there's some obvious, just go psychology, which we've been doing without giant machines looking at brains. So just some key terms, just some language terms that reflect a way of organizing your thoughts. So the obvious one is us versus them. That's going to be true in warfare. It's also true in politics. Politics is organized by social groups. They have sort of, each one has something of a religious character to them in terms of their foundational beliefs. But the warrior part would emphasize us versus them. It would also emphasize winners versus losers. So people with warrior brains are going to really be focused on the winning and not much to the detriment of everything else. And then loyalty versus being a traitor is a big part of this whole way of thinking. So if you start seeing, these are just little clues, if you're trying to identify people who are being more affected by the warrior brain than others, then these are some things. All right. You don't want to have any empathy for the enemy. If you're in battle, you don't want to have any empathy because they're trying to kill you and you need to not die. So this would suggest that people who have the warrior brain are not going to have empathy for people outside of their social group. Deception is an important tactic. Being a carnivore, you're committing deception by tracking animals and sneaking up on them. And deception really works in warfare. There's no reason not to deploy it. But then that can creep over into people today who are operating under the influence of the warrior brain and find deception comes naturally to them. And then probably the most important is anger is a prominent component. So if you're in the middle of battle, the emotions you're going to be leveraging, anger is a really good one. Anger mobilizes your energy sources. and greatly motivates you. So another thing about war, it has a hierarchical command structure. So it took that pecking order idea and applied that, scaled it up in order for, how are we doing? Okay. So you have a single supreme commander. You have foot soldiers who are synchronized by the leaders. And it creates a preference for uniformity in following authority. That is, this has proved to be successful in war. But if it was this strong selection mechanism, that means it's going to have left that structure in everyone to a certain extent. So here's North Korea. Warrior brain culture. Extreme synchronization. This is why I emphasize the synchronization and the social operating system. How do you get these people to be so synchronized? Okay. Just like my example very early on in neuroscience with the Teletubbies, that you start with a couple of ovals, or 3 ovals, 2 for your eyes and the mouth, and then let the neurons go after it with more and more data, you learn. So there's got to be a genetic starter kit, and it's grown through playing during childhood. When I was a kid, I loved to play Army. No one had to teach me to play Army. You couldn't keep me from not playing Army. I loved it, and we all did. It was instinctual. Of course, everything varies between individuals, so we can't not say that. I mean, can't make across-the-board statements. So the activation of the warrior brain is dynamic. It depends upon the situation. And it's a combination, like many things in the human, is automatic and willful control. It's highly programmable, receptive to having the social operating system downloaded from the leaders into our brains. So now let's shift over to politics. So Donald Trump, toward the end of the campaign, demonstrated to me something that was extraordinary. In particular, that was his claim that the election was rigged. So he was doing that just a few weeks before. Okay? And of course, every person who is knowledgeable, and most of these that they interviewed were Republicans, like Secretary of States or Republican Party state leaders, said, no, there's none of that. There's none of that. That's ridiculous. They did polls, of course. They were doing lots of polls. What percentage of people thought the election was rigged? 1 week or so after Trump started saying this. 1 week, about 40%. How many people tend to support Trump? About 40%. Now, I don't know whether they were exactly the same people, but with high probability, they were. So how could this happen? You had to have a mechanism for that. And that's what the warrior brain gives you, that mechanism. Trump had the command structure, the model. He downloaded it in parallel to all these people, and then they start executing the program. Okay, on the right was the counter movement, the resistance, and I participated in Austin's Women's March, and guess what? That activated my warrior brain. I was like, yeah, let's go out and take them on. Who will fight them? So all of us have the warrior brain. It just depends on how strongly it activates, under what circumstances it activates. That's the differentiation. It's not the likelihood of having it. Okay. I need to wrap up here. So let me point out, let me just run through the end of this here. So the warrior brain is in sports. Why would we spend so much money on these arenas to have our gladiators come out and fight each other representing our city-states? And I keep referring to city-states because that was actually the political organization for much longer than anything else. After you got, so nations came, Italy was city-states up until through the 1800s, same thing with Germany. And the marching bands have a precedence. In entertainment, coming back to where I started on all of this, games, video games. Why do people love playing video games? Why do they love all these movies that are violent? War games. Really love it. They eat it up. Well, I would say that's evidence of the warrior brain being activated. All right, so what's our response? Well, we need to have mindful brains. So mindfulness is an American repackaging of concepts from Buddhism and yoga, is a shorthand. And if you're familiar with it, then that's great. But you need to start learning to recognize the warrior brain in yourself and others, and especially political components, because it causes thinking to be less logical, less reflective, more biased, and much more emotional. Emphasize to yourself its genetic foundations and that your mind is the result of brain computation. Do not believe everything your brain tells you. Confidence is just another computation. These politicians who are so incredibly overconfident, that's just a computation in their brain. It's not based on math. Do not argue with other warrior brains. As soon as the spinal cord is activated, discussion ends. So the slide I skipped was about keywords like freedom and capitalism that trigger your spinal cord. We are vertebrates, and I think a lot of our strong emotions like patriotism, we stand erect, and the military trains everyone to have really erect posture, and it really gets the circuits going through the spinal cord. Once that happens, there is no thinking, there's no higher order systems of the brain in operation. So, don't have that happen. Emphasize commonality due to shared genes. Practice mindfulness, which is calm and exhibit empathy. And let me just finish, rather than the warrior brain, we have this other that we've been running in competition, the enlightened brain, starting in the West, ancient Greece, then the Renaissance, the founding fathers of the U.S., and then the human rights movement. And that's my talk.
Thank you for your time.